Hello, this is a match pair design example. Some people believe that different octane gas result in different miles per gallon in a vehicle. The following data is from a sample of 11 people who were asked to drive their car only using 10 gallons of gas and record their mileage for each 87 octane fuel and then 92 octane fuel. So they took one person, they got 10 gallons of gas of octane 87, drove it around, and they saw how far they could drive. They were able to drive 234 miles. And then the same thing over here, they did a second time. They filled their car with 92 octane, and they were able to go 237 miles on that same 10 gallons of gas. So we want to know if there is, and just looking at the first one, it does appear that, right, that 237 is larger than 234. So it does appear that maybe they are getting more gas mileage with the 92 octane, but that's just one example, right? And that's just one type of car. So we need to explore that, and it could be due to other different situations, like maybe how aggressive that person was actually driving and stuff like that, right? So we check it on 10 other people here, so a total of 11 people. We check this. We have collected data to check our feed theory. So they ask us here, do the data support that different octane levels produce different miles per gallon at the alpha equals 0.02 level of significance? They note a normal probability plot of the difference in cars mileage between 87 and 92 indicates the population could be normal, and a plot with no indicators where it was verified. So we can go ahead and do our hypothesis test. This is a hypothesis test for match pair design of mean. So we're comparing two means. So they ask us to express the null retrieval hypothesis in symbolic form for this claim. So I'm looking for when I'm looking, okay, when I'm trying to find the null and alternative hypothesis, I'm really looking for the alternative hypothesis because that was the only one usually that we can find keywords for. So we're looking for the keywords greater than, less than, or has changed, right? So I'm focused on this sentence right here. Do the data support different octanes produce different miles? They don't say more miles, but they say different miles. And so because of this word different right there, this is to me a not equals test because it's not saying greater than, it does not say less than, it says different, which means not the same as, so which means not equal to, right? So what we want here in this alternative hypothesis is not equal. And then our null hypothesis in these match pair design mean tests is always equal. And it's equal to 0 and not equal to 0. And 0 is the only value that we have in our null and alternative hypothesis in these match pair design hypothesis tests like this of difference of two means. Looking for the they say, what is the significance level? We see it right here, alpha equals 0.02, right? Oh, in the line above. Then what is the test statistics? So now we have to run the test and actually find these test statistics. So now it's time to take our calculator. And we're going to enter in now there's a few different ways of how we can do this. I like to enter in all the data I enter the first column here in L1 and the second column in L2. However, you could have also just calculated and then what I do is I make the calculator calculate the differences for me in my L3. However, if you wanted to, you could calculate these differences. And let's be clear here. They ask us express the knowledge term using the form, and then they want to do population 1 minus population 2, and then they verify that population 1 is the mean miles from the octane 7. So this is population 1. The first column is population 1. So L1 will be for population 1. So they do want us to subtract the first population, which is the mileage for the 87 octane. So this is my first population. This first column is population 1. And the second column is population 2. And so they do want us to do sub 1 minus sub 2, meaning the population 1 minus population 2. So that means we do need to do the octane 87 minus the octane 92. Okay. Because that sub value of 1 means that you take, and they say that population 1 is the octane 87, and that sub 1 means population 1. So we are going to do L1 minus L2 here. That they want us to do it in that manner, so we're going to do it in that manner. Okay, so we can either calculate these differences ourselves and then just enter only the differences. So we could do 234 minus 237, and that would be -3, right? We could do 257 minus 238, and we would get whatever we get when we do that. We'd do 2 plus 17, it looks like we would get 19 for that value, and so on. So I could just subtract these across, or I could have my calculator do the subtraction for me all in one sweep. So I kind of like that better. I'm going to go ahead and put these values the first column there, all in my L1. So go to Stat, Edit, and I'm going to go to the top and clear that out. And then I'm just going to put all of them in here. And you can, I'm going to pause the recording while I do that. Okay, now that I have everything in our first column here, I put into my L1. And in the second column labeled, octane 92, I put into my L2, as you can see. And now in the L3, I'm going to highlight the top column, and then I'm going to do second 1 minus second 2. So you see L3, I'm letting it equal L1 minus L2. So what it automatically did is it subtracted the value, the value in the first column minus the value in the second column, and it went and did that for all the columns, all the rows going down quickly. So you can see it finished off all the subtractions that I started to do by hand. So like I said, you could choose how you want to put what you could have done. You could have just put you could have found the differences by yourself using your own calculator and then just put the differences in. It doesn't matter. But we're interested in these differences. That's what we're interested in. Notice how if these differences are large, that means there is a difference between the mileage and when we use 87 octane gas and 92 octane gas, right? So the next step is to do the hypothesis test. So we go to stats and we go over to tests, and then we go down to t-test. We're going to treat this data like a one sample hypothesis test of the means, because we're really just doing a hypothesis test on the differences by themselves. So it seems like one population, even though technically we had 2 samples, right? When we just found their differences, and now we're analyzing the differences. Now we're just interested in the population of the differences. So like one population. I go t-test. The mu sub 0 is always equal to 0 in these match pair design tests. Then the list has to be the differences. So I go back and I'm going to go second 3 to input L3 there. It's supposed to be second 3. Second 3 to input L3, because that's where my differences are. You have to make sure that that list is your differences. Then we choose the frequency 1, it's not there already. And then we also choose not equal to, because that was our alternative hypothesis here. And then we choose calculate, and then I can press enter. Here is my test statistic, the T. It's negative 1.135. So that is the answer to this first part here. Negative 1.3. Oh, it's rounded to 3 decimal places. Rounded to 3 decimal places, that would be, oh yeah, it's negative 1.135. Oh, and I forgot the 1. Then what is the p-value rounded to 5 decimal places? So here's your p-value. It's 0.28283. We could also make the calculator draw this picture for us. So if we go back, stats, and we go back to tests, and I'm going to go back to t-test, and then I'm going to go to draw, and I'm going to press enter. Notice this is what actually is happening. So they're saying that the z-score, it's kind of like it's t-score actually, but it's a lot like the z-score. This particular sample they're saying is 1 point is the test statistic is the number of approximately the number of standard deviations below, because it's negative below the mean. So that's where our test statistic is. And the area under the curve to the left of that is our p-value. However, in a two-tailed test, they go that same distance on the other side, because they're saying that these differences might be as large as that, but the differences might be as as small as this or as large as that on the other side as well. So they've gone the same symmetrically. They've gone the same distance from the center to 1.13 on the other side, and they shaded everything to the right of that. So this is a two-tailed test. The p-value is actually the summation, so of both of the blue shaded regions. Our calculator automatically gives us that sum of both of those areas, so we don't have to double any value. But anyways, that's what our picture looks like. So just so we can be, let me show you again. The negative 1.135 is a value along the x-axis here, and this area shaded along with this is a t distribution, so it's 0 in the center, and then if I go 1.1 in the other direction, then because it's a two-tailed test, we have to do that. We have to do the area under the curve to the right of the positive of the t-value of the test statistic, and the area under the curve to the left of the negative of the test statistic, and we add these two areas together, and that makes up our p-value. Because we want to know what if we had differences as small as these or smaller, what's the probability of that, or as large as that in opposites value or higher. Okay, next. We have to make a decision. We ask ourselves, is the p-value less than alpha? So is 0.28283, is it less than 0.02? And the answer to that is no, it's not. So we fail, or we do not reject the null hypothesis. So that's our choice there in part E. Then they ask us, what is the conclusion? We say there is not sufficient evidence to support the claim. The original claim here, if we look back here, the original claim here is an alternative hypothesis, and it's also up here. Do the data support that there's different miles per gallon for different octanes? And so we're saying there is not enough evidence to show that. So there is not sufficient evidence to claim that there's different miles per gallon due to the octanes. There we go. So that is our solution here. All right, I hope you found this this lesson valuable. Have a great day.